All right, here we are at the bottom of page 1 in 4.4. And we did a whole bunch of graphing. We used the intercepts. You can't see the table of work that we did, but it should be on the page in front of you. We've got our graphs right here. I just want to take a moment and remind you of the equation that those came from, so that'll be on screen. Y equals 9x plus 4. This one is y equals negative 3/4 x plus 6. This one is y is equal to 10x. And then this last one was a horizontal line, y equals 7. So you can see the graph and the original equation it came from. Okay. Our next move is going to be looking at the slope. Now, we reviewed intercepts from 4.2. Now let's review slope from 4.3. Now, slope can be found one of two ways. You can use the formula, which would require 2 points from the line, or you can count it off the graph using rise over run. Okay, so I'm going to go ahead and use the formula for a couple of them, and then we'll use the graph for the other ones. So let's go ahead and we're going to use the formula for the first one, and let's use the formula for the second one, and then we will count off the graph using rise over run on the third and fourth one. Or, since the fourth one is horizontal, you might have that memorized now. There's a slope that always goes with horizontal lines. There's a slope that always goes with vertical lines. So we'll review that again when we get there. So the formula here, if we were to use it, let's pick two of the points. I'm going to go ahead and pick this 0, 4 and the negative 1, negative 5. I'm going to help myself out here and label these x1, y1, x2, y2, and then I'm going to write out the formula every time I use it till I get it memorized here. So my formula is y1 minus y2 over x1 minus x2. And we're going to put all our pieces in here. Now I'm setting up my formula with the fraction bar and the two subtractions because those have to be there. They're part of the given formula. Now all I do is I replace the letters with the numbers, signs and everything. So y1 minus y2, 4 minus negative 5. Okay, the minus is already there and the negative 5 comes with to be replaced. So the minus is from the formula, the negative 5 comes with. x1 minus x2, I've got 0 minus a negative 1. Okay, and what that gives me, and I'll just kind of move up to the top here, what that gives me is 4 minus a negative 5, which is going to be a 4 plus 5, over 0 minus a negative 1 is going to be 0 plus 1, so that gives me 9 over 1, or just 9. Let's use the formula again for this second graph. Again, I'm going to take 2 points off of the graph, and I'll take ones, really doesn't matter which ones you use. We can do both intercepts if you wanted. Let's try that. Let's try 0, 6, and 8, 0. So our 2 points are going to be 0, 6, and 8, 0. Again, it doesn't matter which order you put the points in. It just matters that you line them up in the formula. x1, y1, x2, y2. And you've got our formula of m is equal to, and I'm going to just demonstrate, you can reverse this. It can be y2 minus y1 over x2 minus x1. Okay? Just as long as you line up the pieces. Here's your xy from your second, here's your xy from your first. Okay, and now let's put in our pieces for that. Again, my formula is completely set. It's got to have the fraction, it's got bar, it's got to have the subtraction between the two pieces. Now we just put the pieces in. So y2 minus y1, 0 minus 6, 0 and 6. x2 and x1, 8 and 0, 8 and 0. From that, I get 0 minus 6 is a negative 6, 8 minus 0 is 8, and that reduces to a negative 3/4. So our slope is negative 3 over 4. For this next one, let's count it off over from the graph. Now, This one is kind of interesting because I've gone over a -1/2 here. Maybe I should have used the formula on this one. But I can't use the 0.00 and 00. That won't get me anywhere, so I have to combine these two. But let's go ahead and count this off here. So I need to know rise over run. So as I pick two coordinates here, I'm just going to remind myself what these were. This was 1/2, +5. This was -1/2, -5. This one was 0, 0. How far would we need to go up to go to this point? And we go up 5 and then another 5. So it actually has a rise of up 10. And now to go from -1/2 over to +1/2, it's an entire count of 1. So we go to the right 1, which means that we've got +10 over +1. Our slope is just 10. Okay. And finally, you can count rise over run over this as well. On this horizontal line, pick any 2 points here, and as you look at the rise, to get even with the next point, you don't have to go anywhere. There's no rise. There's 0 rise, no up, down. There's no up or down. But let's say we're going from these 2 points, we'd be going from -3.5 all the way to 2. That would be 5.5 that we would need to go to the right. So +5.5 to the right, and that just gives us 0 over 5.5, which is just 0. Or you can just memorize that a horizontal line, its slope m is equal to 0. Okay? Because it's like skiing, it's still skiing. You can ski this way. It's just very, very flat. There's no steepness to it, so it's just 0 is your slope. Vertical line, we talked about, that is no longer skiing, that's falling. So that is an undefined slope. Okay? Everything else, tilted one way or the other, or flat, is skiing, and so it does have a number that's attached to that slope. Okay, now, let's look at this. Do you notice anything? And I will kind of direct where I'd like you to look, and I'm going to use my handy-dandy bright highlighter here. Okay, we've got the formulas for these 4 graphs. We have found the slopes for each one. We also found the intercepts for each one. So I'm going to highlight the intercept here. Here's our y-intercept, y-intercept. The y and x intercept are the same here. Y-intercept of 0, 7. Okay? And the x-intercept is, intercepts are great, but I wanted you to focus on the y-intercept for a minute. Do you notice anything when you look at the y-intercepts? 0, 4, 0, 6, 0, 0, 0, 7. You look at the slopes, 9, -3/4, 10, 0. And you look at the equation that goes with both of those. Y equals 9x plus 4. Slope of 9, intercept of 0, 4. Y equals -3/4x plus 6. Slope of -3/4, y-intercept of 0, 6. Y equals 10x. Slope of 10, intercept of 0, 0. Y equals 7. Slope of 0, intercept of 0, 7. Now, hopefully some of you are just wish that you could be live here in the studio, so to speak, and say, I can see what it is. Hopefully some of you are seeing that. The connection here is that the number in front of the x, by no coincidence, this will happen every time when you have solved the equation for y, the number in front of x is the slope. Pardon me. And then over here, we realize, oh yeah, y equals 7 is really the same as saying y equals 0, x plus 7. It's like the x has been multiplied by 0, pardon me, and it's dropped out. And so there's our slope right there, and still in front of the x term that we don't see. And the next thing is that the y-coordinate of the intercept. In other words, when we plug 0 in for x and x falls away, it just always leaves this number. Remember how I mentioned that 0 is easy to plug in because it just makes this go away and you're just left with 4. When you plug in 0, it makes it go away, you're left with 6. When you plug in 0, it goes away, you're left with, well, in this case, left with 0. You plug in 0, well, there's nowhere to plug it in here, you're just still left with the leftover number, the 7. So there's that y-intercept. This is your y, this is where it crosses the y-axis. It's the y-coordinate of the y-intercept, to be more specific. Okay, so let's put that into words here. What do we notice? We notice that the number in front of x the one that's being multiplied by x is the slope. And we know that the number being added is the y-coordinate of the y-intercept. Now, not only is this kind of a fun realization, this is the key to becoming an expert grapher. So, when a linear equation is solved for y, this is the key element right here. When a linear equation is solved for y, you can look at the equation and see, without having to do any calculations at all, you can see the point where it's going to cross the y-axis, the intercept, the y-intercept, and you can see the slope, how it moves, what's the steepness of that line. So when you have y equals mx plus b, m is your slope, and b is the y-coordinate of your y-intercept, where it crosses the y-axis. I'm going to make sure I'm still on screen here. Good. Oh, getting close. Pull that down just a little bit. Okay. So when a linear equation is solved for y, you can see the y-intercept and the slope. In front of the x is your slope. The number that's being added here is your y-coordinate of the y-intercept. But the key is it has to be solved for y. Y has to be by itself on one side. This is what I call instant graphing. This is what we've been waiting all of chapter 4 for. What I've been waiting all term for. This is just one of my favorite sections to teach. Instant graphing. Okay? Now we've talked about this before, that all you really need to draw a line, you really only need 2 points. Once you're confident about the 2 points, you just connect the dots and extend the line, and there you have the graph. But to be even better at it, to be able to go from the equation to the graph, really all you need is one starting point, or beginning point, and then the pattern or slope of the movement of the line, how it goes from one point to the next, how you move to the next point. How to move to the next point on the graph. Okay? And we're going to move on to the next page in the next video and practice this. And we'll practice first with the equation, just identifying the slope and the y-intercept, and then we'll get to the point where we can go straight from the equation to the graph. Okay, we'll see you on page 2. Good job.